Muchas gracias. Muchas gracias a todos por venir. Voy a hablar en inglés because I don't want to say anything that I don't mean. I don't speak Spanish very well, so sorry for that. But I wanted to take some time to talk to you about Google Chrome. I'm very excited to be able to finally talk about it. I've been working on it for about 2 years, so it's not in secret, so it's nice to be able to speak about it in public now. We launched it earlier this month to a very overwhelmingly positive response, and we've been very happy to see how much people like it so far. We have a long way to go, and we have a lot more work to do. But I'm here mostly to talk to you about the features of Google Chrome and to show you some of the things we've done. But before I do that, I wanted to talk to you about why Chrome is so important to us and why browsers are so important to us at Google. So we spend a lot of time online. We're doing more and more stuff online. We spend a lot of time online as users and also as developers. We're starting to spend more time using email online. We're starting to do our documents and spreadsheets online. We're starting to use products like the ones that we talked about, that Alfonso talked about, like Picasso Web online. We're trying to use more and more things and share more and more resources on the internet. And all those things and all those services that Google's working on come to users through the browser. So the browser is very, very important to us. We want to make sure that users have a very, very nice experience when they're using their browser. And we thought, we should take a look at the way the web works today and take a look at some of the services and some of the advanced things we're doing with browsers today and make sure that the platform and the architecture makes sense for those types of applications, and also the types of things users are doing online should be supported very well by their browser. So that's the biggest reason why we started to work on Google Chrome, and that's another reason why we decided to open source the whole project. It's not so important that everybody uses Google Chrome. It's important that the innovations and the approaches we're taking are getting out into all the browsers that people are using today. So let's talk a little bit about how the web has changed. So I'll open up Google Chrome, and I have a bunch of pages here that I want to go through. So hopefully the internet will work a bit better than it did for Alfonso. So here, the first page is Excite from 1996. I went to the Internet Archive Wayback Machine and pulled up Excite. This was a state-of-the-art page at the time. But as you can see, the web has changed a lot. If you look at this page, it's mostly a bunch of links. There's some images, and it's using a table to lay everything out. And that was pretty state-of-the-art at the time. And I'll even use the Web Inspector in Google Chrome to show you how that works. So here, as part of Google Chrome, we have an inspector that lets you see the content of the page. And you can see that this is pretty much a table layout here. There's a table used to structure the page. And as I mouse over different parts of the code, you can see which parts of the page are working. And all of this came from Webkit. Webkit is the rendering engine behind Google Chrome. The Web Inspector was part of Webkit. So we were very happy to get this as part of that project and part of that integration with Google Chrome for free without any integration on our part. Now, if you think about the kinds of things we're doing online today, they're much different. They're much more advanced. We're not just using tables for laying out pages. We're not just using simple images. We're using lots and lots of JavaScript. And we're using lots and lots of divs and CSS and lots of fancy stuff that wasn't around. So I'll show you a few more sites. This is Google Maps. And I think this is where we are right now. But there's a lot of JavaScript and a lot of stuff going on under the covers to make this all work. This isn't just a simple static page that has one load. They're using XML HTTP requests. They're using lots of CNS, lots of CSS, lots of image loads, lots of stuff to make the dragging maps work. And that stuff wasn't really part of what we thought about when the original browsers were built. So when we started to think about Google Chrome, we started to think about what new pieces of infrastructure do we need to develop, and how do we need to think about these pieces of infrastructure to make sense for today's web. Another good example of a site that's very advanced is Flickr. So I searched yesterday for some pictures of Mexico City, and you have this really nice view where you can see a spreadsheet, see a slideshow of all these different images coming through. And you never would have thought to see something like this in 1996 when browsers were more state-of-the-art. So we thought it makes sense to take a fresh look at browsers and makes sense to try to see what we could do. So there are three main areas on the back end of the infrastructure for Google Chrome that we wanted to innovate on. We wanted to take a fresh look at. And one of them is Webkit. I already mentioned we use Webkit for the rendering engine, which is really, really nice for layout of pages. It's an open source project that Apple uses for Safari. And as we thought about our choice of rendering engine, we wanted to make sure to not make life any more difficult for webmasters. Webmasters already have to test their site in a variety of different browsers to make sure that it works properly and it lays out properly and looks right. So we didn't want to introduce yet another rendering engine so that you'd have another slot in your testing matrix. So we were very committed to choosing an existing rendering engine. And I'll talk a little bit more about Webkit in a minute. The other thing that was important to us is to make JavaScript run really, really fast. JavaScript was never really designed to do the kinds of things like Gmail and maps and some of the really advanced stuff that people are doing in JavaScript, where a lot of the application logic actually operates in the browser on the client. You're not actually going to the server for a round trip on every single command. So we wanted a JavaScript engine to run really, really fast and scale to those sorts of demands. And the third area is the entire architecture of the browser. We've gone with a multi-process architecture to the browser in order to give some nice properties of stability, security, speed, responsiveness, and we'll talk about that as well. So first, let's spend a little bit of time talking about Webkit. So as I mentioned, Webkit is the rendering engine in Google Chrome, and it has some very nice properties for us. One of them is that it has a lot of momentum in the mobile space. It's the rendering engine in the browser for our Android project. It's also the rendering engine in Nokia's browser. And there's lots of other small projects that are using Webkit as well. So we're very excited about seeing all that momentum in the mobile space. We see mobile growing quite a bit. We're also very excited about how accessible the code base was. It's a very light code base. It was something that our engineering team was able to pick up really quickly. But the most important reason for us to choose Webkit was the speed. And it's just a very, very fast rendering engine. Of course, speed is the most important thing in a browser. So we wanted to make sure that we picked one that was really fast. So I'm going to do a little demo. And this is actually the same demo and the same test that we did when we were evaluating our rendering engine. So I'm going to copy this link. Oops. And I'm going to run this in IE. So you can see what Trident, the rendering engine in IE, does. So this actually loads a series of pages from my disk, so the network isn't involved, 5 times over, 5 different pages, and then measures the amount of time it takes. So you can see it going through the pages. It goes pretty fast. And at the end, it will output a score that says how many milliseconds it takes per average to load a page. So that's sort of a good baseline for us. And we decided, let's take a look at some of the other options out there and see if we can get anything any faster. And here, I'll run the same thing in Google Chrome. And you can see it's way faster. In fact, it's about 3 times faster. So we were really excited about that. We thought it was a great opportunity to take a fresh perspective, fresh approach, and bring a much faster user experience to users. Now, the other area where we wanted to get a lot of speed was V8. And as I mentioned earlier, the speed of JavaScript execution is a bottleneck for a lot of applications today. A lot of web developers try to avoid using JavaScript, at least in a very intensive way, because it creates a slow experience for users in some cases. You can't do very complicated things in JavaScript. You can't do some of the intensive things like cryptography and write games in a browser. That seems like a crazy thing to do if you're going to manipulate, handle all the application logic in JavaScript. So we had a team of VM experts come to us, and they said, we'd really like to make JavaScript fast. We'd like to take a shot at it. And we thought, it's kind of crazy. I don't know if it's going to work. We don't want to take a big risk on something like JavaScript because it's so important to us. But we'll let you go and see what happens. So we have a team of specialists who work out of Aarhus, Denmark. Actually, they've worked on many, many VMs in the past. And they went off working on one of the engineers' farms for a while until they got office space near the university in Denmark. And they worked to make JavaScript faster using modern techniques for making languages faster. Now, in some cases, they had to cheat a little bit because of the way JavaScript is used today. It's a dynamic language. And they wanted to use some of the techniques for more structured programming languages, like Java and Smalltalk, where they had great success before. So they took those approaches and applied them to JavaScript. And we've created a benchmark suite that helps us measure how well we're doing. And we've optimized against this benchmark suite. And to be really clear, it doesn't necessarily represent what people are doing on the web today, because webmasters have optimized for very specific use of JavaScript, namely the kind of JavaScript that's available in browsers today. So we wanted to make this is more of an aspirational benchmark. It's a benchmark that represents where we want the web to go and what kinds of things we expect people to be doing in a browser in the future, and what kind of rich application types of things people want to support in their applications in the future. And of course, we have lots of feedback from all the apps at Google that are trying to push JavaScript forward, like Gmail and Maps. So without further ado, I'll run the benchmark. And this is actually on the open source project website. So you can go there and run your own browser in that site and see what happens. So it's actually running through a bunch of standard benchmarks and compiling them together to see how many we can get through in a set period of time. So a big number is good here. So you can see we're getting about 1,500, 1,482. But I'll do the same thing in IE. And I do this with a little bit of fear because sometimes it causes things to behave badly. We'll see if it works today. It's going. Looks like it's going to make it 43. So as you can see, V8 is way better. It's way faster at doing these kinds of operations that we expect to be very important for developing future web applications. So that's V8. Now the next area I promised I would talk about was the multiprocess architecture. So in Google Chrome, along with taking a fresh look at the JavaScript engine and reevaluating all the rendering engines, we wanted to take a fresh look at the whole architecture for the browser and how all the pieces fit together. Now, one of the pain points that we feel when we use the web is you're using a bunch of different tabs. You may have, a shopping site open. You may be buying an airline ticket. You may be communicating with someone about your travel plans. You may be researching your travel plans. All kinds of different tabs open in various states of progress. And something bad happens in one of those tabs. You click a link, and your browser crashes. And now you've lost everything. You have to start completely over, start from scratch. And that's really painful. We curse that all the time. I'm sure you guys have experiences like this where your browser crashes. Or something bad happens in one of the tabs and everything starts to go really, really slowly. And your browser hangs. And then now you can't interact with any of your tabs. So we decided to explore this idea that one of the engineers had for moving all the tabs into their own process. So that means that each rendering engine runs in its own process. Each tab is essentially its own browser. So if something bad happens in one of those browsers, the rest of the tabs still work. The rest of the windows still work. And everything works really well. And the other cool thing about this is we're able to use a separate process for the Chrome of the browser. So all the tabs up top, the back and forward buttons, the URL bar, all that stuff runs in the browser process. So that means if something is happening in one of the rendering engine processes, one of the tab processes, something gets stuck there or something crashes, or because you're running the arbitrary code from the JavaScript and all this stuff from the site itself, you can still switch tabs. You can still close the tabs. You can still type into the URL bar. So let me simulate something interesting happening there. And I'll actually use the task manager that's built into Google Chrome to show you what's going on. So we decided, like the Windows Task Manager, we wanted to give people a view into what was happening in their browser. What are all these tabs doing? Which ones are consuming resources? Which ones are consuming, which ones are stuck, if anything like that were to happen? So here, let's see. You can see what's going on there. We can see how much memory is being used by each of these, how much CPU, how much network. And if I do something in one of these tabs, let's say if I run my benchmark suite again, you can see that the CPU will shoot up. You can see here's the process that's running the benchmark suite. It's using lots and lots of CPU as it goes through this. And you can see what's happening. Now, if I were to simulate a crash, I can do that by using this bookmarklet. You don't lose the whole browser. Instead, you just get this sad tab that shows you something bad has happened. But you can still switch tabs. You can still close this tab if you want. And you can refresh to get back to where you were really easily. So it's a really nice insulation against bad stuff happening in your browser. And that was something that we were tremendously excited about as we worked on Google Chrome. Now, the next thing I wanted to talk about is some of the other benefits to the multi-process model. So as you see, we've pulled all these tabs into their own process, and that's given us nice isolation. But it also gives us some really nice properties of security. We were able to take each process and make a boundary around the process for security's sake. And we call that boundary the sandbox. Now, the sandbox allows us to limit the kinds of things that a renderer process can do. So each tab tries to execute all the code that it's running. But sometimes there are malicious websites out there that try to get stuff running outside your browser. They try to get malware installed on your computer. And by building a process around the tab or building a sandbox around the process that's running that code, we can prevent it from doing some of the nasty things that it might be trying to do. So For instance, we can remove all the privileges of the render process. That means that it can't write to your disk, and it can't read from your disk. So it can't try to steal any information from you. It can't talk to the other tabs when it shouldn't. And it can't try to leave malware behind on your computer. And from the bad guy's perspective, this is really bad news. Because now you have to find both a bug in the rendering engine to get your code to do something that we didn't want it to do. But you also have to find a bug in the sandbox to get your code outside of the sandbox and into the person's computer. So we think this is a great step forward in terms of security. We've had a privilege of being able to architect our browser in the era of modern web exploits, where the bad guys are doing all sorts of creative stuff to try to get malware installed on your computer. And looking at what people are doing today, we were able to build an architecture that fundamentally disadvantages some of those approaches and makes some of them completely impossible. So we're very, very excited about that. And we hope it makes people safer online. Now, the next thing we've done for security is we've used something called Google Safe Browsing, which is used in Firefox as well. It's a series of blacklists that are pulled down automatically to the browser. So that if you could try to go to a page that's trying to do something bad, and we update these lists very frequently, we'll actually warn the user that they shouldn't go there. Now, there are two types of bad sites that people end up going to. One of them is a phishing site, and those are pretty straightforward. Usually, the owner of the phishing site is doing something bad. They want to steal your information, and they make their site look like another site in hopes that you'll type your password in so that they can steal your password, then use it to get access to your bank account or something like that. The other type of site is a malware site, and this is becoming a more prevalent threat on the web today. And most sites that host malware aren't actually bad sites. They're actually good sites. And as webmasters, this is something that you should be very aware of and very wary of. A lot of times what happens is your web server will get compromised. Someone will hack into your hosting service, and they'll put bad code on your site without you even noticing. Oftentimes it's in an iframe or something that's not even visible to you as a user. You'd have to examine your code to notice that it's there. That will try to inject bad code into your site that tries to exploit the user's system. This is very bad. It also happens when you syndicate some of your content to either some shady ad networks, or possibly when you're putting a counter or something on your site and you don't control the JavaScript. Sometimes there's bad JavaScript that leaks in there. And the Safe Browsing service uses Google servers to scan all the sites out there and look for bad stuff happening and look for exploits trying to occur. So here, I'll go to a site that we've set up as a demo site that actually is hosting some malware. And the browser has a blacklist, and this site's on the blacklist, and it warns you before you go to the site as a user. As a webmaster, you can click on this link to diagnostics to learn more about what the problem is, so you can clean up your site and then work with us to get the warning removed. But we think this is really, really important to help keep people safe online. There's nothing worse than not being confident in being able to surf around the web and worrying about bad stuff happening to you when you're just trying to use the internet. So this is a really important effort for us as well. So it turns out that I like to do a lot of shopping online, and the Omnibox and Google Chrome have learned about what I like to do and which sites I like to go to. So by only typing A, it's already realized that I want to go to Amazon.com. So with 2 keystrokes, A, enter, I can load that site, which saves a lot of time. It's one of these features that after you use it for a little while, it just seems to know what you want to do. And it's very nice. It's very hard to live without once you've started using it a bit. Now, I don't always just want to search. I don't always want to navigate. Sometimes I want to search. And let's say I want to search for Mexico City rude food. I can search directly from the Omnibox, and it will go directly to google.com or whatever search provider I've set up as my preferred search provider. We actually import your search provider from your previous browser. So it's very nice. You see, it's really easy to search from google.com. It's very easy to navigate, especially to pages you've been to in the past. But what about all those other search engines that you like to use a lot? You might not always want to just use Google to search the web. There's lots of other search engines I use. I use lookups on our company intranet. I use Amazon to look for products and services. I like to go to Wikipedia a lot. And it turns out there's a really nice search engine in Wikipedia for finding information. So let me search for Diego Rivera. So I want to see some of his work while I'm here. And I'm doing a search on Wikipedia, but Chrome at this point has noticed that there's a search engine on that page that I like to use. Just by virtue of having done the search there, I don't have to set anything up. Chrome has noticed that there's a search engine there. So that next time, when I go to Wikipedia, there's a little tip here that says press tab to search. So I'll press tab, And let me search for Frida Kahlo. And I'm doing a search directly on Wikipedia from the Omnibox. I didn't have to do any setup. I didn't have to do anything special. Chrome just learned that there's a search engine I like to do. I didn't have to navigate anywhere. I just start typing the URL, and it gives me this very handy tip for going there. It's probably my favorite feature of Google Chrome. And I use it a lot. It scales to hundreds and hundreds of search engines without any trouble at all. Now, as a webmaster, if you want to take advantage of this, all you need to do is publish an OpenSearch declaration file. So I'll show you where to find more information on that. OpenSearch.org has information about publishing this declaration file. And by putting this at the root of your site, it's a little bit of XML. You can guarantee that Chrome will find your search engine as people search past your site and search on your site. We also have a bunch of heuristics in Google Chrome to try to do this even if you haven't published an OpenSearch description document. So it will work most of the time, but you can assure that it's going to work if you publish one of these at the root of your site. And again, you can find that at opensearch.org. Now, the next feature that I want to talk about is the new tab page. Just like the Omnibox learns where you like to go and customizes itself without any intervention on your part, we wanted to help people get where they're going visually with the mouse when they open a new tab. When I open a new tab, I'm telling the browser, I want to go somewhere. I want to do something. So let me do that right now. I'll open a new tab, and you can see what Google Chrome has created for me. These are all the pages that I go to most often with a nice thumbnail, so it's easy to recognize and easy to get back to. These are the same search engines that we just talked about being discovered as I search the web and use search engines. These are the bookmarks I've created recently. And if I happen to have closed some tabs, there's an easy way to get back to them. So I can quickly click on these, and it will reopen the tab, and it will remember all the things that were open in that tab with the back button and things like that. So it's a very quick and easy way to get back to tabs that I might have closed accidentally or closed and then realized I needed to use again. And again, all of this works automatically. You don't have to customize this page. You don't have to do any setup. It just works based on your using Google Chrome. Now, the next feature that I'd like to talk about relates to some of the applications that we were speaking about earlier. People tend to spend more time in the browser using things like Gmail and Google Docs and Calendar and Reader. And these things are long-lived applications. They don't really make sense just as tabs because you tend to leave them open all day long. I know I have my email account open all day. I have my calendar open all day. And I get them lost in the sea of tabs that are more or less temporary. I open them up, use them for a little while, close them. And I often find as I have Gmail open a tab, I'll accidentally close it, or something strange will happen where I just can't find my Gmail window. So we have this feature, and I'll show you how it works, called Create Application Shortcuts. So first, let me go to Gmail, and I'll log in. And here, under the page menu, I'll choose Create Application Shortcuts. And it gives me this nice little dialog that explains to me what's going on. I can create shortcuts on the desktop, in the Start menu, or here in the Quick Launch area. I'll just create one in the shortcut on the desktop for right now. And you can see what I've got. I've got a nice little shortcut here. And when I click on that, I get a window without any of those other browser controls that I don't need. I get a window that just has a freestanding window that doesn't have a back button, which can be dangerous if I click on it and send me back to a site I didn't want to go on. It doesn't have a URL bar where typing into the URL bar will take me away from my email. It doesn't have a refresh button or any of that stuff I don't need. It all lives under this menu. So I can do any of those things I want when I want to, but it minimizes the accidental clicks, and it makes a lot more space for my email and the content I want to see in my calendar. It also is very nice for switching. So I can use Alt-Tab, and I have a nice entry in the Alt-Tab menu. So I can get to that just like a real application. And I also have a separate item in my tray down here, so I can switch to it really easily. And we find that it makes a lot of sense for people who are used to using desktop applications, who want to have these long-lived applications running and don't want them lost in a sea of tabs. These things start to really feel like real applications. Now quickly, if you have an application that you want to make work really well in this create shortcut mode, you can actually go to our FAQ. And here there's an explanation on how to specify a shortcut and a name for your feature, a name for your shortcut, so that it works really well when you get that Create Application Shortcuts dialog. So I'll use our Find in Page feature to find the right section. So here I'll hit Control F to use Find in Page. and I'll type application shortcut. And I don't know if you noticed this, but as I typed, all these little hash marks appeared in the left margin of the tab, so you can see where the matches are. I'm not actually looking for this one, but I am looking for these matches down here. It's really easy to find the right ones based on the hash marks in the scroll bar. So here you can see you can publish a nice shortcut title, a nice description, and give us a nice shortcut icon so that that dialog looks really nice for your web application. If you don't publish one, we'll try to do something nice. We'll use the page title, and we'll use the fav icon so that you get something that works. But if you want it to look really pretty like Gmail has, you can publish use this meta tag to publish some of that information on your web application. Now all the features, all the create application shortcut, and all the advanced features for web apps are made possible through something called Google Gears. And Gears is something that we've integrated into the browser. It's part of Chrome. And it's a plugin that also runs in other browsers. It allows you access to certain things like an offline. It allows you to make your sites work offline. For instance, you can access an API called Worker Pool, which will allow you to run threads, run scripts in the background. It will also allow you to access a database on the local machine so that you can make your site work offline. Gears also allows you to create the application shortcut, and there's a whole bunch of other features and functionality that's going into Gears. We're looking at things like a geolocation API, so you can figure out where the user is coming from. There's support for drag and drop, and a lot of this stuff will be done in the standards bodies moving forward so that we can help push the platform forward and we can do more intense things in applications. Now the last feature that I wanted to show you is called incognito. And there's lots of different uses for incognito. People talk about lots of different things they like to use it for, but I'll first tell you what it is. So I'll open a window. There's a nice description here that explains what's happening in incognito mode. But the idea is that it prevents information from being stored on your computer. You can have a private browsing session. You can go to any kind of site you want to, and none of that information will be left on your computer. So to show you how it works, I'll do a search. I really got on Lucha Libre. Maybe my boss, I don't want my boss knowing that I've been doing all kinds of fun searches on the side at work. And I'll do a little browsing here, load a few sites, and then just to prove that nothing's going on, I'll close this window, ending my incognito session, and go to history. And you can see that none of the search for Lucha Libre isn't in there. The site that I went to isn't in there. The only thing that you see is the stuff that I was doing in my other window. Now there are lots of obvious uses for incognito, but one of the non-obvious uses is actually to use a separate account. So you get a fresh cookie store when you create an incognito window, which means that if you have two Gmail accounts or you have two accounts using the same cookie-based authentication, you can actually log into a separate one. So you can see that I'm actually logged into Gmail here. When I go here, I get this account. But if I create a second incognito window, oops. If I create an incognito window and then log into, try to go to Gmail, I can actually use a separate account here, which is pretty nice if you just want to temporarily check an account. It's not really the intended use of the feature, but it's a nice hack. Now, if you find yourself doing this a lot, there is a feature in Google Chrome that makes it really easy to use a separate profile with a separate cookie store. And if you find yourself having a separate account for your webmaster stuff from your main personal account, you can actually modify the shortcut in Google Chrome to use a different directory. So here you can see there's a little flag at the end, and this is sort of an insider trick. But you can use that flag to create a separate profile. So here I'll copy this shortcut, and I'll create a second one. And I'll go in there, and I'll modify this one to use a different data dir. So the flag you want is -- user data dir, and I'll call this one temporary. And now if I launch this one, I get a brand new profile, and I can accumulate any kind of browsing data I want here. So I can have a separate one. I can name it, maybe I want this one to be my work account, and the other one can be my main account. So this is one of the hidden features of Google Chrome. The last thing I want to talk to you a little bit about is our open source project. So everything we've done in Google Chrome is open source, and it's all available on chromium.org. Here you can see all the code to the project. You can see development ongoing. If you find bugs in Google Chrome, you can report them through our issue tracker. And if you're finding bugs in your site, if you're finding incompatibilities, it's probably our issue. Everything we're treating right now we're treating everything right now as an issue that we need to fix. So as webmasters, if you're finding incompatibilities, especially if you're finding incompatibilities that work in Safari but don't work in Google Chrome, please report them to us, and we'll fix them. You can report them here on the open source project. There's a really easy way to do it in the page menu here, where you can report a broken page or website here at the bottom. And that will send us a screenshot, and you can add some information to explain what's going on. So thank you very much. We hope that you help us out a bunch when we try to make Chrome better. I hope you try it out, and we hope you like it. Sí.
Uso Firefox como diseñador. Uso Internet Explorer para ver que las páginas sean compatibles. Uso 3 exploradores. ¿Por qué usar uno más? ¿Por qué complicarme la vida con uno más?
This was something that we wrestled. This is a question we wrestled with a lot. We didn't want to introduce yet another browser with no reason, and we thought that Firefox is doing a great job of spurring innovation in the browser space, and we're very excited about the things that they've brought to the table in terms of making browsers better. However, given web applications and the changes in architecture, we wanted to take a fresh approach, and we wanted to see what would happen if we took a completely different approach to see if we can make browsers work better both for users and for developers who are trying to build cool stuff for users. So some of the things that we talked about, like V8 and multiprocess architecture, would have been very disruptive in an existing browser and very difficult to pull off. So we wanted to do it. At first, it was more of an experiment. Let's see if these things work. We're not sure if they will. We don't want to destabilize an existing product that's doing quite well. And let's see if we can make it have a fundamental change in the architecture of browsers that will allow us to push things forward even further. So that's what we did with Google Chrome. We tried some crazy stuff out, and some of it worked out, and that's what you see today in Chrome. I'm very excited about what the team has accomplished, and I think it's significantly different from the other browsers, but we'll leave it to users to see.
Me gustaría saber eventualmente por qué cuando hacen ustedes el lanzamiento de Chrome, lo hacen solamente para plataformas relativamente avanzadas. En mi caso particular utilizo una Windows XP que no tiene el servir pacos. El navegador es imposible de utilizar, ya no se diga en Linux ni en Mac. Y una observación, también tengo mi cuenta de correo dentro de Google Apps. Para mi sorpresa, cuando entro por primera vez en Chrome, dentro de una computadora que sí puede utilizarlo, la función de Google Apps para los correos me dice que la página no es visible y no me deja entrar. Simple y llanamente no pude entrar a mi correo que está dentro de Google Apps.
Okay. So the first question about Mac support and Linux support is a good question. Obviously, we're very committed to making sure that our software runs on all different platforms. And we are working very hard on a Mac and Linux version. So that is something that's in progress, and hopefully we'll have more information to announce in terms of timeline in the future. We thought it was really important to get the prototype, get the beta out there, and start getting user feedback so that we can make it better as quickly as possible. We started out with the Windows version just because it made more sense to focus our efforts in one area. However, as you point out, it's very important for us to have support for Mac and Linux, and that's something that we are working on as our top priority right now.
It's also about prior versions prior to service pack 2.
I see. So in terms of support for earlier versions of Windows, we focus our efforts on where the users are. In fact, Microsoft doesn't support those earlier platforms either, and it's very difficult for us to get some developer support to support those programs. We actually have lots of automated testing and automated infrastructure that runs simulated versions of the platforms that we support in a lab to make sure that the system works very, very well. So it's very, very difficult for us to support legacy versions of Windows that aren't even supported by Microsoft anymore. That said, it's an open source project. So if we can get a dedicated supporter for some of these platforms that will do all the stuff that we need to make sure that it's a very solid supported platform and we don't have strange bugs, then we'd love to have help out there. In terms of Gmail, I'm sorry, I haven't worked on Gmail for a couple of years, so I can't say why you may be having trouble with the service, but I can help get an answer to your question if we can follow up later with the Gmail team.